What's up guys, how have you been? I'm really excited today to present you this new tutorial video, especially for steel connection design using idea statica. Today we are talking about how we can use a Gusset plate to design some complex connection like for a truss bridge. So today we will show you for some demonstration how you can easily from zero to this such as a result, how you can design, how you can modeling, how you can make some connection boards and how we can make some design, some verification plates and bolts, weld and make analysis for such as complex connection chain in using a Gusset plate. Why I'm not talking about the Gusset plates, but it's very using in the structural and connection for metal frame and for the structural bridge for some truss bridge like this it, that connection is very important. So maybe you can ask me the question why I'm not talking about. So it's very important to talking about this because we need to create it. We need to have some knowledge. We have some information about to do it because some more of professional do it better. They no respect some rules, some standards, some specification, structural specification about this. So some when you don't respect some rules, some standards, some methods of design, drawing, and calculate this such as complex elements of steel connection structure. So there is some many damage, some many problem in the future with the real life. So why the big deal? Why we're talking about? Because they are reversed for centuries, and if you are not structural engineers, you will never notice them, and it's okay. They should be made like this and inconspicuous use, but with the specification for Gusset plate. So there is some norm, some standards that we can use it for United States. We have the American Institute of Steel Construction. We have CSA for Canadian standard, and we have the Euro Code 3 for European environment. So this is some such as, and this some basic type of Gusset connection we can found. We can use it from different projects, bridge, tall buildings, from the space frame, and so. So without lose time, we'll begin our demonstration. So I'll go ahead here and add the project. So it's not important for me for now. I can just open a new so I create a blank project. I have the bolt assemble M30 with class 8.8, the steel grades and the concrete grade. We will not use concrete grade, it's just working with steel element. So I have a blank space. I have a user interface of idea statica, and after what you can do, you can see here it's very blank. So I will working with firstly to create member. For member I'm using some I-beam and they're using from HB 300 millimeters, and click OK. The geometry type it be continuous, and after I have it, so just copy and put some ended and rotate it to 90 degrees, and this one I'll just rotate it to 90 degrees too. Not for the beta, that is just for the alpha angle. I rotate it for this, and this one I'll rotate it from 19 degrees. So I have it, and after to do it, the next is to copy again, and there I just change here. I change just the angle. I have it, and copy again. I change the angle. I put one. We have it. It's very fast. You can see very fast. When we go transparent, we have it. So we need to put some kites, so to be able to have the ability, the possibility to make a good a cutting edge, cutting off all elements. This you need to create, you need to add some plan. We'll go to manufacturing, operation manufacturing. So you need to add some working plan, you need to create some working plan. So we will, in this example, we will create three working plan. So this is our first working plan. We go to Z, you put this number and we have it. This is our first, and I copy. To copy, I will change here. To change, I'll put rotation here, and I have this. No, sorry. This is one. I can go here. This is our second cut plan. Our third cut plan, just minus this. So we have our cricket plan. Have to do it. You need to go operation manufacturing operation. Go to cut. So our first cut will be the member tree. Member tree with our cut plan. Our cut plan 1. You see, it gives us the first cut. You copy. You do our second. Will be with M3 with this, and we cut M3 with the second cut plan. We have it. So we copy again. We go for the M4 cut with M working plan 1, and we copy again. We have 3. So as you can see, we have all our cut section. So the working plan allow you to make some complex cutting when we're working with idea static. It's very important, these tips, to know to use it. After to do it, the second tips is to add my Gusset plate. So to go up manufacturing operation, we go there, transparent. I have it. So in this plate, the thickness I work on 20, and after for the width 1600, high 1600, and the origin are working with members. So from my members, I will working with the top flange and working with double. I have it. So in here I can put it. I have this. I can change for Wedner. No, top flange, yeah, double. Here I can go both. No, both is not an import. Okay, wait. So I have it. Excuse me. I can begin. I begin again, and I must change the members type. So top flange here, the double. I have it. So I go here and 60. I have it. So when I go to the plus the W, the plus Y, and I can see here, I must change this, modify this editor. From editor, I'm going to chamfer, and put 300, and copy again. I go here, put 4. I have it. I apply. This is my first my first Gusset. So no welding from this side. Yeah, I can go there. No, it's not this, but because you can see from how our modeling, yeah, that's okay. There is no problem. it's okay. So I need to copy twice again and change for the bottom flange, and here I may change, put this double, and here I put this, so it's okay. There you can see I'm finished to design my stiffener, no, not my stiffener, my gusset plates. After to finish to modeling my gusset plates, I may change 20, and for these two I put 20. You can see it changing the thickness. Yeah, that okay, great. And after to do it, I must create some stiffener. Our stiffener can find it. It can be there. Gusset plate. I just already finished to create my gusset plate. I need to create this stiffeners. So I'm going manufacturing operations and go to the stiffener, change. I have it. So the X positions, so the repeat count 3, and the delta 100 down tracks 150. That okay. I can change. You can check. Our gussets are there. We just finish our stiffener. The second things, I can be the last things, is to create the bolt. So from our bolt, how to create. So go to the manufacturing operations and go to this bolt grid contact or contacts. The class of bolt assemble and the diameter of my bolt. Okay, I have it. This is our first. So I need to make my positions. My positions will be a 325 millimeter of set, and after the rows 200 and 100, the distance of the bolts twice. I have it. So the rows 75 minus 150. So I have it. That okay. So I can go at this without to do this. I can no. It's the same. It's the same. It's the same. So I'm going here and have the same level. Minus 85, 800, 850, 850, and after minus 100 twice. I have it. This is my first bolt. As you can see here, you need to make some parameter. You need to change, because here it will be my first. It will be SP1 with this my top flange M1. Top flange M1. I have it. So copy again. 500. We have it. And we put 100 twice. We have it, and after we have this and this, we have it. That is okay. And we will put copy. After copy, to be quickly, it will be SP2 with button M2 button flange, and you go there. We have it. That okay. And after you go there, transparent, you put copy, and after copy you need to change this. need to select. We have bottom flange, top flange M3. We have it with SP1. After select this 0, we have this, and at this place we put 100 of offset 2. We have it. We can remove, we put this, that okay, we can put that okay, this, and we have this. Excuse me, from my side, that is okay. We put the same for the bottom. We have it, bottom 2, bottom flange 3, and we can verify it's okay. We have it. We back here, we go to the last, our last diagonal bolt work, copy 7 bolts connection, and we have M4 top flange with SP2. We copy, we go M bottom flange with SP1, and when we go there, we finish our modelizations. Everything is okay. When everything is okay, we can just verify. We see it's suitable from our meeting needed. So after to do this, the next things to do is to add our loads. Go to load equilibrium, import load equilibrium, after exports, we have it. Go to Excel, copy, and go there, paste, replace existing load. That's okay. And that's where we can see, we can calculate. Everything is good. We owe it. It will give us some result, which will help us to check. You can see plates, the ratio, but the rest of of modelizations of work, weld and bolt working, it's good. So we can go to the checking results and go to the equivalent stress. You can see some results. Yeah, this is our result made it. So you can add mesh to have a good overview. That okay. So you can see here, you can add some force inside the different loads, different bolts. So you can check here. You have it. You can verify your model. You can put some screen capture. You can put in your work. You can see some results, some reports here. So we can see here a plate. We have it. We can verify. You can see some of the deformation. These are deformation about. So when you only have these capabilities to interpret the result, so you can put some good decision for the project. Maybe you can increase or decrease the stiffness of the plates. Maybe you can add, you can increase the diameter of our bolt, and so it's depending of the structural analysis made in maybe some robust analysis software, SIA, Sophistica, the Global FM, or maybe Midas, and so there is many software for structural design. So after to do it, you can verify the deformation, strength check. You can see it. You can check plastic strength, the plastic deformation. You can see we have some result. You can verify for the bolts. You can see here some manual verification according to the error code. Here you can see the bearing resistance and so on, so on, and so on. And when you go back to the analysis, you can, after to check everything, you see everything is okay. My design needs some change. You can verify, you can decrease or increase the plate, and so to have to fix all the some message error, and there is a remark warning. So after to do this, so you can see, okay, my calculation verification for Gusset plate joint design is okay. After, you can just go to the report, and from the report you can generate automatically the reports, and you can export it from PDF or from Excel, from Docs, Word, and so DXIF. If you want to verify or put some drawing presentation in AutoCAD, you can just it. If you were to a bill of materials, you can find it, and you have our model. We have some verification, the first model and the second model for our members. There is some problem about the deformation. A verification starts, but here it's checking it's okay, it's pass. So after verify it fail, so you can just verify according some rules. Here you have some value, you have some forces, some moments, some bearing moments. You have all these units are according the error code manual verification code setting. You see each members, each value, each coefficients have is a reference from error codes. This is error code 3 to have a more information table if you want to have further information about. How to do is you can generate the bill of materials, because when we go back to the design, you can see it give us, if you want to make this manufacturing operation of this plate in the factory, in the workshop, it costs you some dollars. It depending on the currency. When we have it, you can comment, you can make some comments, and you can use this drawing to use it in the workshop to produce all assemble from our Gussets, and so that is okay. But because the technician in the factory, they can just use it, they have all the dimensions, so they can use it to produce in detail with accuracy everything you want. That was just a small demonstration about how we can use the CBFM in using idea Statica to design some complex connection joints with the trusser steel bridge. Thank you so much. This is the cost of producing this. It was a pleasure for me to present to you. See you later for the next video. Thank you so much, and happy Easter for every Christian and for no Christian, and God bless the Democratic Republic of Congo. Bye bye.